this problem we have a firefighter who's skating towards a fire with a fire extinguisher, and he lets the fire extinguisher go and it generates a force of 60 newtons, which is going to slow him down a bit. And he generates this 60 newton force over 5 meters while he skates towards the fire. What is his final velocity? We know his initial velocity is 4 meters per second, and his total mass, including all his harness and tank and everything, is 102 kilograms. Okay, so what we're going to do is just conservation of energy here. So energy initial equals energy final. Okay, 1/2 mv squared plus mgh. The height is 0. We define it as 0. He doesn't change height at all. All he changes is velocity. So 1/2 mv naught squared equals 1/2 mv final squared. But we have work done in this case. There's work done by the fire extinguisher. Now, when we consider work done, work net, whatever you want to call it, is equal to force cos theta times distance. Now, the whole point of this cos theta is so we have the work done in the direction of travel. So if we're looking at, say, the work done by his weight is 0 because he doesn't change height. His weight acts in a y direction. No work is done by that force. Work is done by the force of the fire extinguisher because it's in that direction. There's some in that direction. In this case, it's all of it. All of it's in that direction. So it's force times distance. Now, in this case, cos theta, since it's acting opposite the direction of motion, is going to be 180 degrees, which is going to make this negative. So actually, the work done by this force is a negative work. But we're not going to put it in there as negative. If we were to put it in the work net equals kinetic energy final minus kinetic energy initial, then it would be, we'd put it in here, it'd be negative, it works fine. What I'm going to do is show you how we can do it just by looking at where the work comes into play. Okay, we know initially we have this much energy, and finally we have a certain amount. We know this is how much initially, and finally we have less energy because we know that this force has stopped us a bit. So what we have to do is add the work done in by the fire extinguisher. So work is force times distance because it's all in the same direction. It's not off at an angle. So we add this in to get our total amount of energy finally. And all we have to do is solve for V final squared. So what I'm going to do is say 1/2 mv final squared equals, so I'm writing this term out, I have 1/2 mv naught squared minus f times d. So I can solve for Vf squared. I have Vf equals 1/2 mv naught squared minus force times distance. I'm going to put this in brackets because I'm looking at my Vf. I'm multiplying by 2, dividing by m, and that leaves me with my Vf squared, and I just take the square root of this whole side. So I just multiplied the 2m over to get that. Now, all I have to do is plug in the numbers. So I have square root of 1/2, with the brackets there, my mass is 102 kilograms. So I have 102. My initial velocity is 4. I'll square it to give me 16. Minus the force of 60 newtons times the distance of 5 meters. I'm going to put my big bracket around that. Times 2 over 102. So all I have to do is multiply this, subtract off this number, multiply by 2, divide by 102, take the square root. So you do all that, and you get a final velocity of 3.18 meters per second.